Hello everyone. Welcome. My name is Jonny Lyse and this is Arne Klæboe. We work with IT security at Intility. Today we're going to talk about ransomware, commonly known as CryptoLocker, TorrentLocker and so on. First, a short introduction of the environment me and Arne have been working in for the last 10 years. Intility is a managed cloud service consisting of two parts, the industrialized technical platform and our complete management service. By letting 200 specialized technicians focus on this one service, we ensure high quality, which manifests itself in a stable customer base. Arne and myself are some of the people who work to protect this platform against threats like ransomware. There have been several types of ransomware over the last years. This graph is from Google Trends. It shows how the word ransomware is entered relative to the total search volume across the world. As you can see, it started showing up in 2006 and has been increasing, reaching all-time high December 2015. We expect this trend to continue. The early versions of ransomware tried to scare users by locking their computer, impersonating law enforcement. Then they claimed that the user had done something illegal and would need to pay a fine in order to avoid legal prosecution. Basically, they lied in order to get you to pay them. When that wasn't successful anymore, the malware creators started encrypting the local files so that the user wasn't possible to get access to his own files without buying the key to unlock them. So now the user paid them to get their photos back and everything else you store locally on your computer. Today's versions of ransomware not only encrypts the local files, but it also encrypts the files the user has access to from his computer, such as company network file shares. Some even threaten to publish your files online for everyone to read if you don't pay up, often with a short deadline. At this point, your company will probably pay because the malware has encrypted company data. This article was on digi.no yesterday, and it shows how we are right in that this is a continuing trend and it will continue to increase. This is the latest trend in ransomware. It's called ransomware as a service. Anyone capable of Googling can start their own ransom campaign. All you need to do is 1 hour of research and you are ready to start spreading your own personal malware installer. With ransomware being this easy to get started with, we think it's very likely that the number of ransomware campaigns will increase. So, in order to defend against today's ransomware, it's important to have several layers of protection. This is often referred to as a kill chain. Our demo's simplified kill chain contains 4 parts, where each part, if successful, will cause the ransomware infection to fail. In today's demo, we will start off with all our lab security features enabled. Then we will turn them off one by one until we are infected. Then we will show you how to detect and mitigate the infection. And finally, how the restore process can be simplified. Arne, let's take a look at the lab.
Thank you. So, we have set up a lab to demonstrate this. In this demo environment, we are using one Windows 10 workstation as our client. On the workstation, we are running AppLocker as the only security feature. AppLocker is a built-in functionality in Windows. This allows administrators to whitelist applications that are allowed to run. This whitelisting can be done by a security certificate. You can use the file signing of the executable as a means to whitelist it. You can whitelist a file hash, or you can whitelist a location, a folder, or a file path that is allowed to run. Then we have a Windows 2012 R2 file server. This file server is running a custom script we use to monitor file encryption activity. I will get back to this later. It is also using volume shadow copy to take backups. This is a built-in functionality in Windows. It allows you to restore a file to a previous version based on a snapshot or a shadow copy that is taken on regular intervals. Then we are using Splunk as our log management tool. Splunk is a big data log management system. It allows you to collect logs from almost anything and search through them. You can create alerts based on a search generating a result. And we will collect the logs from our custom script on the file server with Splunk. Finally, all this is connected together with a PA200 firewall from Palo Alto Networks. It's the one you can see here. This is the smallest firewall they provide. On the firewall, we are using DNS, IP, and URL filtering as a feature to block known malware sites. And we are using the built-in antivirus feature. This is a functionality that when a file passes through the firewall, it will be scanned by an antivirus engine on the firewall. And if it contains a known virus, the firewall will block the traffic. Finally, we are using anti-spyware feature on the firewall. This feature will, among other things, block command and control traffic from botnets and malware communications. So with this setup, I will go into the workstation. Just switch screens here. Yep, it's there. Good. And the workstation is running Windows 10, as I said earlier. On this workstation, we will simulate a user. The user is, for some reason, expecting a package and has received a link to a malicious site claiming to be the package tracking site. And of course, the user will click this link. So I placed it here for convenience, and I will double-click the link. And as you can see right now, the link is not opening. This is because the traffic has to pass through the firewall, and the firewall is blocking all traffic to this site because it is a known malware site. So at this point, even though the user clicked the malicious link, the infection did fail. And the user is protected. Nothing bad has happened yet. Since that's not always the case, we will simulate that the firewall failed this protective measure, and I will make the computer bypass that firewall rule. I will not make an actual change on the firewall because that's quite slow. It takes several minutes to do the to commit that change. So instead, I will change my my IP address. When I change my IP address on this computer, I will no longer hit the rule that blocks known malware sites. So with my IP address changed, I will click the link again. And this time, the page loads. And many of you have seen this before. This is an actual campaign that went out early last year. They have modified the campaign recently, and it's ongoing again now. What it says is that you have a package, and you can click here to get the adresselapp that you bring to post office to get your package. And as a user, of course, I click this link because I want my package. And again, I'm protected. So this time, the file transfer is blocked. And this is due to the firewall not allowing virus traffic to pass through the firewall. It has detected that this is not a file that can be transferred over the network, and will not allow the user to get this file. So again, I am protected. And the infection has still failed, even though I actually arrived at the web page and I clicked the link to download the file. And again, I will simulate that this protective measure fails. I will change my IP address, and this time I will no longer hit the rule that blocks virus traffic. I will open the website again, and I will click the link again. Let's see, F5. And this time, I'm allowed to download a file, and I will click Save. I open the folder, and as you can see, the file is located on my computer. So, at this point, the local antivirus client could have scanned the file and cleaned it or removed it. In my case, as you see, it didn't. So, as the good user I am, I will click this file yet again, and I am protected by AppLocker. As some of you may notice, this file is not actually a Word document. It looks like one. It seems to have the extension .doc, but it is actually an executable, and it's not whitelisted by AppLocker. So still, I'm not allowed to run this file. And yet again, the infection has failed. And still, I will simulate that AppLocker failed. There are ways to bypass AppLocker, and maybe this was used at this point. To do that, I will just disable AppLocker. I will open local security policy and go into the application control policies. In there, you can right-click AppLocker and change enforce rules to audit only. This will make AppLocker log everything that happens instead of actually blocking. This can also be done through group policy, of course. So if you have a real environment, you will use group policy to roll out changes to this. So with AppLocker in audit-only mode, I will start the application again. And this time, it starts. And as you can see, it's not a real virus this time. We have created a demo locker. It's a CryptoLocker demo program. It will simulate all the functionalities that is needed for the normal ransomware to work. So the first thing this program will do, it will try to establish a connection to Google to check that it's online. That's one of the first steps in the malware, in the inner workings of the malware. After that, it's going to try to contact its command and control center. The command control center are the servers online that the malware users, the malware creators use to control the malware. So this is the place where they will send out commands to the malware. They will send out updates. And most importantly for this case, this is where the malware will get its encryption keys. Most encrypting malware will download encryption keys unique for this specific infection and use them to encrypt files on this machine. As you can see, this software is not allowed to download, or it's not allowed to connect to the command control center. And this is because, yet again, the firewall is protecting by blocking known command and control traffic. So even though the installer was able to run on the machine, the user is not completely infected and the infection has somehow failed, but it's getting close now to actually doing some harm. So to bypass the blocking of known command control traffic, I will yet again change my IP address. This time with 53 as my IP. I will restart the malware, and now it's able to connect. And as you can see, it has now connected to the command and control center. It has downloaded its unique encryption keys, and it has started to encrypt files on the areas this user has access to. And those areas are mapped up at G drive, so it has started on this drive letter. And the malware is not actually able to encrypt files on all the folders. As you can see now, it's looping through each file, and it's not getting access to write because we have set up NTFS permissions on the folder, so that our user can only write to his own department's folder. And this will limit the scope of the damage this malware can do. And right now, it has gotten down to Department 3, Pictures, and this is where this user can write. And it has started to encrypt files on the Pictures folder. And now the protect phase has definitely failed, and we are entering detection mode. So how do you detect this? The most obvious way is for the user to detect it. The malware will often notify the user that it's actually there. So, for instance, open pictures like this and instruct on how to decrypt your files. And of course, the user will notice that some of the files are broken. In the picture folders here, we can see that some files not working, other files they are still looks fine. And the malware has placed a file or several files in the folder called help decrypt or something along those lines. These are files that contain all the instructions on how to pay the malware creators, how to get on to buying bitcoins and send them to the right place and get your key so that you can decrypt your files. So if this was if I was a good user, I would of course call my service desk or the security department and get help to decrypt files, stop infection, anything that should be done. But I'm not, so I will just close these windows and go and get a cup of coffee. And and when I do that, the malware will run in the background and continue to encrypt all the files I have access to. And that's of course bad. So as an administrator, you need some other ways to detect that this is happening. And to do that, in this demo, we are using Splunk, and we have a PowerShell script that runs inside a Splunk application. This PowerShell script is... Oops. Great. What's wrong? Yeah, I'm infected. Yeah, that's one of the problems. I actually lost my D drive. So the drive where the virtual machines are stored just offline in Windows.
Didn't you switch IP?
Sorry?
Didn't you switch IP?
Not on the base computer. So I switched on one of the VMs. So I'll just quickly try to take a look in disk management to see where my drives are. Okay, I'll reboot the machine. That's the Windows fix. So what I was about to say is this script is using the built-in Windows file system watcher. That's the built-in API in Windows that allows you to set up a filter and get notified if a file matching this filter is created. And in our environment here, we have a script that contains several of the known help decrypt file names. When a file or folder is created with a name matching that list, the script will trigger an event. This event will be picked up by Splunk. And in Splunk, we have created alerts on those specific events. So when we get one of those events, help the service desk and the monitoring departments will be notified. It's back. Great. And that's also the case in our environment here. So as the files are getting encrypted, we will get events popping up in Splunk. just need to get the Splunk server online again. Yeah. If you don't have a Splunk environment, you can also use this script and change it. You can, instead of generating an event for Splunk, you can send an email. And we have included just a line for that, so you can uncomment it and you can write in your own SMTP server, and you will get the ability to send an email to a specific mailbox. You can monitor the mailbox for emails, and based on that, you can react. These events, they contain the server name, and they contain the path to the actual help decrypt file, and they contain, in some cases, if it's available for a script, the username of the user that has created this file. And I'm not able to show you here, but the event would have shown this information, and based on that, I could go onto the file server. So that's what I will do now. I will go to the file server, and on the file server, in order to stop the file encryptions, I will go to the share that I know that the user is encrypting files on, and I will change the sharing permissions. This is also something you could script depending on your environment. So if you know that it's safe to block sharing permissions, you can make the script just do the command for set share permissions and deny this specific user write access to the share where he is encrypting files. And this can run automatically in the background. And if it's safe for your environment, it's maybe a good thing to do. There's also an option built into to Windows called File Server Resource Manager. This is another way of doing the same thing. You can create file groups. These file groups can contain the known names of the help decrypt files. And then you can create file screens which run a script each time this is triggered, also blocking or notifying your search desk. But this is not easy to roll out in a big environment, and it's not that good integration with Splunk, so we're not using it right now. So getting back to the area that is encrypted, based on the events, I could see that they were in the data and groups folder, pictures, under department 3. So to stop the user to being able to encrypt more files, I will just change the sharing permissions here. I will set everyone to read only, or I could also put deny on the specific user. And I will go back to the workstation. Let's see if this is getting online. It is. So we will start the virus. It's probably still here. And if this works, we will see that it's no longer able to encrypt files on the server. And yeah, it's looping through now. And we'll soon get down to the folders where the user actually has write access. But since I changed the sharing permissions, the user will not be able to write to the files, even though he actually has NTFS permissions. So at this point, we have mitigated, or at least we have stopped the infection from causing more damage. And we can start the procedure of locating the user or users and getting their machines cleaned, or maybe reinstalled, depending on how you handle infected machines. So this concludes the detection phase. We now have a basic way of detecting it, and we can go on to the cleanup procedure. And to clean up, we need some way to identify only the encrypted files, because we could, of course, restore the whole file server, but that would probably cause damage to files that have been worked on during the day and not actually been encrypted. So what we are going to do then is try to figure out what files are encrypted, what files are not. And as far as we have seen, there have been two major ways of doing that. One of them is that the malware is actually changing the file extension on the files. When that's the case, you can just do a simple dir/s and search for .encrypted or .locked or whatever they choose. If that's not the case, and that's the way it is in our lab here, the malware is actually changing the file header. So in order for the malware to be able to know which files it can decrypt, it will scan through the files and look for the first bytes, the start of the file. That will be identical for all files encrypted with this specific infection. And we have made a script for searching for file headers. This script is run on the file server. I will start it here. It takes a sample file, so I have to have one file and know that it's encrypted, and that shouldn't be too hard. I will go into the pictures folder on department 3, and this is broken, so it's encrypted, and I will get the path for this file, paste it into the script, and click get header. Now the script has extracted the start of the file, and these bytes, they are the first part of the file. Now I can just choose where I want to search for this file header and click get files. Now this script will search through all the files, and it will generate a list of all the files that contains this specific file header. And this can take some time on a huge file server, of course. On my here it was quite fast. It found 10 out of 79 files that were encrypted. I can export it to a text file, and we could, for example, send it to the backup department, and they can then restore these specific files only and not touch anything else. This will obviously save you some time and pain when you're restoring. Or if you have volume shadow copy enabled, as we do here, you can open a known good shadow copy. This is done by right-clicking on the folder and choose previous versions. In here, we get a list of all the shadow copies, and I know that the one I took at 12.12 was before the infection. So I will double-click it, and now we are into this shadow copy. And then we can take the path to it and paste it back into the script. And for some reason, the path to this shadow copy is not what's written in this normal path field. You have to right-click one of the files and select properties. And in the location field here, this is the actual path where you can get to this folder via PowerShell and other scripts. So I will copy this path, paste it into the script, and click restore. Now the script has copied only the broken files back from the shadow copy into the file server. I can verify that everything is working by going back to the client, and we can go into the pictures folder and look at the thumbnails. And they are looking good. So this file, for example, it's working. So it's restored from the shadow copy, and we no longer have a broken file. But still, we have a couple of help decrypt files here in a real scenario environment. These files would have been spread all over, and yeah, it's nice to get rid of them as well. So we made a small addition to the script that allows you to check the delete help files checkbox and click detect. This will delete those files. So at this point, we are back in normal state on the file servers. The client has probably started the cleaning procedure, and everything should hopefully be back to normal. So, Jonny, can you summarize? If I just get this to work.
So, now we've shown you some ways you can protect, detect, and recover from a ransomware infection. In our example, the files that were affected were on a normal Windows file share. The newest ransomware also encrypts files on cloud storage like Dropbox and OneDrive. So if your files are located on a cloud storage, make sure you pay for the ability to restore files when needed. Our lab's protection consists of next generation firewall functionality, where we block known malware sites and recognize command and control traffic. As you can see, there are more available protection mechanisms available that you can deploy to secure your network and your endpoint. Updating your software is an easy and especially important part of this. You need to manage and deploy Flash, Adobe Reader, and Java updates, as well as operating system updates. We've also talked about the importance of limiting users' access to file shares. No, everyone does not need modified permissions on all the folders. They really don't. We also demonstrated how you can be alerted that an infection has occurred, either by raising user awareness or by alerts generated by events from our script. The reason we think this kind of alert will continue to work is because the malware writer's #1 mission is to make money, and if you don't know how to pay them, they won't get paid. So they need to leave something behind visible to the user. For now, this is detectable. Finally, we went through the recover steps, including quickly blocking share access to the shares to stop the ongoing encryption, searching for file headers to identify encrypted files, and restoring the encrypted files without affecting unencrypted and potentially modified files. Also, don't forget that since your antivirus didn't stop the malware, you should provide your antivirus provider with a copy of the file so they can help prevent later infections. We hope you found this interesting. The scripts we have used are available at this URL. Thank you. Any questions?
You can come up later also if you want.
Yeah, you can talk to us
we
later.
will pick down here.
All right, thank you.